Hey, welcome back to Unit 6. We're looking at exponent rules here today. And so we want to start off with a little bit of vocabulary here. So we're going to be talking about exponents, which are these numbers written as superscripts. And exponents are always attached to a larger number, so they're always hanging off of that larger number, which we call the base. And a combination of an exponent and a base is called a power. Okay, so with that in mind, let's take a look. We want to go through some of the different rules on how we can use exponents to keep life a little bit simpler and easier for us. We'll take a look at some examples, write them out in expanded form so that we can start to figure out what the pattern is, and then we can solidify our rule before we start practicing those. So if, for example, we want to take something like 3 squared times 5 squared, I could write that out in expanded form and say 3 squared is 3 times 3. And 3 to the 5th is 3 times 3 times 3 times 3 times 3. And then I'd say, well, how many 3's do I have all multiplied together? I actually have 7 of them, so we could say that that is 3 to the 7th. If we try 2 times 2 to the 6th, go ahead, pause the video, give that a shot. And here is what we should see. I've got 2, there's my first 2, times 2 to the 6th. And so how many 2's do I have multiplied all together? We should count that we have 7 2's multiplied all together, so we'd say that that is 2 to the 7th. Now this also works the same way with variables. If I have b to the 5th times b to the 8th, you might want to pause and try it. And this is what we should get. I should have b to the 5th times b to the 8th. And if I count up all those b's being multiplied together, I have 13 b's being multiplied together. So we'd say the final answer, b to the 13th. So take a moment, fill this out, and say, hey, what do we think is going on here? If I am multiplying bases, what do I do with the exponents? If I'm multiplying together bases that are the same, like 3 and 3, or 2 and 2, or b and b, what do I do with those exponents? And let's try a couple more examples. So a to the 3rd times a to the 4th is a to the 7th. A to the 1st times a squared is a to the 3rd. A to the m times a to the n, well, there's a new one. It should be a to the m plus n. So as long as my bases are the same, like a, then all I'm doing is adding the exponents. And we can sort of see that y up here. If I have 2 3's multiplied together by 5 3's, well, it's really just 3 times itself. 1, 2, 3, 4, 5, 6. We've got 7 3's multiplied together. So this is called the product rule. Take a moment, test it out on number 3. And when you're ready, unpause the video and check the answers. And so if I have 2 to the 6th times 2 to the 8th, well, I add 6 and 8, those exponents, and I get 2 to the 14th. For b, we want to remember if I have no exponent given, it's presumed to be a 1. So I take 3 plus 1 plus 5, and I get negative 7 to the 9th. M times m to the 5th times m to the 6th should give me m to the 12th. So let's take a look now at the power rule. Well, what if I have a power raised to an exponent? So if I have 5 squared, we can rewrite that as saying, well, 5 squared is 5 times 5. And if that's cubed, well, then I write that group once, twice, 3 times. Now, since these are all being multiplied together, I can just count the number of times 5 is being multiplied together, and I get 5 to the 6th. So take a moment and try writing out the expanded form for 8 to the 5th raised to the 4th, and x cubed raised to the 4th. So 8 to the 5th to the 4th should look something like this. I've got 5 8s multiplied together in groups, and I have 4 of those groups. So if I count all of the 8s, I should find that I actually have 20 8s being multiplied together. So I could say that this is 8 to the 20th. If I do x cubed to the 4th, I'm going to have x cubed, or x times x times x, 4 times. So if I count up all those x's being multiplied together, I get x to the 12th. So look at the table above, and then in your own words, describe what you think the pattern is. So what's going on? And so if we look at this, what we can kind of see happening is that if I have a power raised to an exponent, I am multiplying the exponents together. So 2 times 3 gives me 6, so it's 5 to the 6th. 5 times 4 gives me 20, so it's 8 to the 20. 3 times 4 gives me 12, so it's x to the 12th. And so if I have something like a times m to the n, my final answer is going to be a to the m times n. Okay. Whoa, come on back. I'm really hoping I didn't just end my video. Okay. All right. So what we call that rule is the power rule. So let's try and have you practice on these examples below for number 3. So pause the video when you're ready. Go ahead and unpause and we'll go through them. All right. So if I have 7 to the 4th to the 9th, I'm going to do 4 times 9 and get 36, so I'll have 7 to the 36. If I have k to the 17 squared, I'm going to multiply 17 and 2, get 34, so I'll have k to the 34. W to the 100 raised to the 20th is going to give me 100 times 20, or 2,000, so I'll have w to the 2,000. All right, that's another one of our rules down. So let's take a look next at the quotient rule. So if we write this out in expanded form, I have 6 to the 9th, or 9 sixes multiplied together on top, and 6 to the 4th, 4 sixes multiplied together on the bottom. Now I can cancel out anything that appears the same in my numerator and the denominator, because anything divided by itself is 1. And so if I start eliminating things, I have a 6 on the top and a 6 on the bottom, a 6 on the top, a 6 on the bottom. What I'm left with is 5 6s left on top. And so the final answer is 6 to the 5th. Go ahead and pause the video and try the expanded form for the quotient rules for these. All right, so if I have 100 cubed, I'm going to have 100 times 100 times 100 over 100 squared, or 100 times 100. Now if I start crossing off the numbers that appear the same on the top and the bottom, I cross off one pair of 100s, a second pair, and that's everything I can eliminate. All I'm left with is 100 over 1, which is 100, or 100 raised to the 1st. Now if I do t to the 15th divided by t to the 11th, we got 15 t's on top, 11 t's on the bottom. I'm going to start crossing off one off the top and one off the bottom. And what I'm left with is I have an extra 4 t's left on top. It's going to be all written over 1, so my final answer is t to the 4th. Now take a moment, pause the video, and think to yourself, maybe write down here, in your own words, how would we describe the pattern that we're seeing? How do I go from 6 to the 9th over 6 to the 4th and end up with 6 to the 5th? 100 to the 3rd divided by 100 to the 2nd leaves me with 100 to the 1st. All right, and hopefully what we're seeing is that I take my numerator and I subtract, or I take the exponent from my numerator and subtract the exponent from my denominator. So we're just finding the difference between those. And we can see why. It's only the difference that remains after everything else has been canceled, after all the parts that are the same have been canceled out. So we could say a to the m divided by n is equal to a to the m minus n. So we might be able to take something like a squared over a to the 3rd, and we're going to get a negative answer. We'll end up with a to the negative 1. Now hold on to that thought. You might have thought that would give you something else, and you're probably right, and we'll talk about what that other thing is. All right, so go ahead, pause the video, and practice out the quotient rule on the problems below. Okay, so I'm going to look at a here. Both bases are 16, so all I'm going to do is subtract the exponents. I'm going to end up with 4 more 16s on top, so I end up with 16 to the 4th. Let's try b. I'm going to have to multiply across the top, so I end up with w to the 25th over w to the 10th. I subtract 25 or 10 from 25, and I get w to the 15th. So different ways to do c. One way is you could combine the powers on top. So 4 to the 3rd times 4 to the 7th gives me 4 to the 10th. And now we can apply the quotient rule, and I get 4 to the 5th. We could approach this differently, and we could say it's 4 to the 3rd times 4 to the 7th over 4 to the 5th, which if I cancel, or if I, apply the quotient rule, is going to leave me with a to the 2nd. So I will get 4 to the 3rd times 4 squared, and I will end up with 4 to the 5th. Again, that 4 to the 3rd stays there. 5 4s get canceled off the top by canceling out the 4s on the bottom, and I'm left with 4 to the 5th. Next, we've got the power of a product. So what if we have some multiplication going on inside parentheses and then the whole thing raised to an exponent? So if we write this out, we could say that it's 2 times 5 quantity cubed. So I would write 2 times 5 times 2 times 5 times 2 times 5. And if I rearrange it, put all my 2's together, I get 2 times 2 times 2 times 5 times 5 times 5, and I get 2 cubed times 5 cubed. Go ahead and try that here in expanded form with the next 2, and unpause the video when you're ready. So if I do 3x to the 4th, I could write out 3x 4 times, and now I can rearrange it. I'm going to have 4 3's multiplied together and 4 x's multiplied together, so I get 3 to the 4th times x to the 4th. Or, because I can take 3 to the 4th and get 81, I get 81 x to the 4th. And if I try the next one, I'm going to do the same thing. Remember, if I have an exponent raised to an exponent, I multiply those together. So I'm going to get 7 squared, or 7 times 7, times y to the 3rd, times y times y times y, times z to the 4th. So 4 z's, and the whole thing is going to be squared, so I got to write it again. Well, now I can regroup my 7's. I have 4 7s multiplied together, 6 y's multiplied together, and 8 z's multiplied together. So I would say it's 7 to the 4th, y to the 6th, z to the 8th. So take a moment, pause the video, and write down what's the rule that describes what's happening here. Okay, and so what we can see is happening here is that this exponent can effectively be distributed as long as these things are being multiplied together. We won't be able to do this if we have to cross addition or subtraction. Those are separate terms, and it will not give us a correct answer to try and distribute across those two terms. But here, we can do that. So if I have x times y to the b, we could say it's x to the b times y to the b. So go ahead and try the power of a product rule on the questions below and give that a shot. Okay, and so here's what we should see. We should see 3 to the 7th times 5 to the 7th. We should see 17 squared times w squared. We should have 2 to the 9th times a to the 3 times 9, or the 27th, times b to the 10 times 9, or the 90th. So let's take a look next at the power of a quotient rule. Well, what if I have a fraction being raised to an exponent? What happens then? Well, let's look at this example. 3/5, if I write out 3/5 squared, it just means it's 3/5 times 3/5. Now to multiply fractions, I multiply my numerators and I multiply my denominators. So I end up with 3 times 3 over 5 times 5. Well, 3 times 3 is just 3 squared, and 5 times 5 is just 5 squared. If I try that again, where I mix variables and numbers, we'd see m over 8 to the 4th would be m over 8 times m over 8 times m over 8 times m over 8. Well, that's the same as m to the 4th over 8 to the 4th. So there's my answer. If I have negative a over 9, and I square it, I'm going to pull out a negative 1 here and take that negative and square it. So a negative times a negative is going to give me a positive, and then I can just focus on a times a is a squared, 9 times 9 is 9 squared, so I get a squared over 9 squared, and that'll be my final answer. Watch out for those negatives. So take a moment and describe, what do you think the quotient rule, or the power of a quotient, really means here? Okay, so here's what's really happening is if I have x over y to the a, I can say it's x to the a over y to the a. It's like the exponent is being distributed to both the numerator and to all the terms in the numerator and the denominator. Okay, now go ahead and try that on the problems below, and when you're ready, unpause. Okay, so if I have 5/4 cubed, I'm going to end up with 5 cubed over 4 cubed, or 125 over 64. If I have 2x over y to the 7th, I'll end up with 2 to the 7th times x to the 7th. It's just like I'm distributing that exponent to both bases, and then to the bases in my denominator. So 2 to the 7th is 128, so I end up with 128x to the 7th over y to the 7th. And then finally c, again, I'm going to pull out that negative 1. I'm going to raise that to the 8th. And then I will raise a to the 8th and b to the 8th to end up with, all those negative ones cancel each other out to become positive, and then I'm left with a to the 8th over b to the 8th. All right, so let's talk about zero exponents and what that is going to equal. So if I have x to the 4th divided by x to the 4th, we might say, well, anything divided by itself has to equal 1, and that's true. But if we think about a rule for dividing exponents, x to the 4th divided by x to the 4th should be x to the 4 minus 4, which would mean it would be x to the 0. So which is it? Is x to the 4th divided by x to the 4th 1, or is it x to the 0? And the answer is it's both, because anything raised to the 0 equals 1. So if we think about that here, try it out, 32 to the 0 is 1. 2,827 to the 0 is 1. Anything raised to the 0 is 1. Now we could think about, if we had x to the 0, we could say, well, that it's really 1 times x to the 0. That's still the same quantity. If I multiply anything by 1, it's still the same amount. And we might say, if I have x squared, I write x times x. If I have x to the 1st, I write x once. And if I have x to the 0, I don't write x at all. It's like it doesn't exist. But what am I left with? Well, that 1 that we were multiplying by is still there. Next, let's take a look at negative exponents. So if we look at powers of 2 here, we have 2 to the 0 is 1, 2 to the 1st is 2, 2 squared is 4, 2 to the cubed is 8. And we can see that as we keep going, we're just doubling. Well, we could take that thought and play it in reverse. If I go from 2 to the 4th to 2 cubed, or 2 to the 3rd, I'm dividing by 2. And 2 cubed, going down to 2 squared, I'm dividing by 2. And I'm dividing by 2, and divide by 2, and here's our negative exponent. Well, we're going to take 1, because anything to the 0 is 1, and then we divide by 2. And I get 1/2, 1/4, 1/8, 1/16. Now, something else you might start to notice is 2 to the 1st gives us 2. 2 to the negative 1st gives us 1/2. 2 squared gives us 4, but 2 to the negative 2 gives us 1/4. 2 to the 3 gives me 8. 2 to the negative 3 gives me 1/8. And so what we can see happening here is that negative exponents take a number and flip its position in a fraction. So if I have 1/a to the negative 5th, I can take a to the negative 5th, and I can flip its place in the fraction to make it positive. And so I end up with a to the 5th on top. Now, the 1 here is still up there on top, but I left a 1 on bottom to really stress that if I take anything off the top or bottom of a fraction, I always have 1 left. So if I can move everything, we just leave a 1 behind. So if we try x to the negative 4th, go ahead, we could say that it's 1/x to the 4th. If I have 4 times a to the negative 2, take a moment, pause the video, and see what you get. So here's what we can see. The 4 actually doesn't have a negative exponent, so it never moves places in the fraction. The a, which is raised to a -2, does have a negative exponent. So we're going to take it from the bottom of our fraction and write it on the bottom. And so our final answer will be 4 over a squared. So this is a great time to engage in some independent practice. We've gone through all the exponent rules. Take a little bit of time, go through these, and see how you do and what questions you have, and then unpause the video and we'll go through the answers. Okay. So if I look number 1 here, I have the same base, so I'm going to add my exponents, and I get 2 to the 16th. If I look at 2, I can see that I've got 4 times itself 17s on top over 4 times itself 15 times on the bottom. So I can subtract those exponents, and I get 4 squared, which is 16. 12 to the -4, I want to write that as with a positive exponent, so I'm going to write it 1 over 12 to the 4th. Four is just a lot of multiplying. So I take 3 times 4, I get 12. X squared times x, I get x cubed. Y to the 4th times y squared, I get y to the 6th. So all we're doing is multiplying one base at a time and just applying the product rule. X cubed to the 6th is going to be x to the quantity 3 times 6, or 18. We could see that written out in expanded form there. 3yx squared, quantity squared, is going to give me 3 squared, or 9, x squared times y squared. 1 over y to the -5th. Well, I've got that negative exponent, so let's flip its place in the fraction. I just end up with y to the 5th over 1, or just y to the 5th. Anything raised to the 0 is always 1. Same base, so I add my exponents, and I get 3 to the 14th. I'm going to distribute my exponents here, so I get 6 squared, or 36, and y squared to the y squared squared, so I multiply those together, so I get 36y to the 4th. Bases are the same, so I'm just going to add my exponents and keep that coefficient in the front. I get 7b to the 6th. A to the -4th raised to the 7th. We're going to say is a to the -28th, but I want to leave it as a positive exponent, so I'm going to flip its place in the fraction. I take everything off the top, so I'm left with just 1, and I have 1 times 1 over 1 times a to the 28th. B to the 7th times b to the -3 over b squared. I'm going to first combine my bases on top. So I'm going to add 7 and -3 and get b to the 4th. I have b squared on the bottom, and I'll apply the quotient rule and come up with b squared. We're going to take x to the 3 times 5, or 15, and y to the 4th to the 5th. So I just multiply those exponents together, and I get y to the 20th. So here's 15. So this one's starting to get into some multiple steps. So I'm first going to distribute that cube to both the x and the y. So I get 2 to the 3, or 2 times 3, gives me x to the 6th, and y to the 1st cubed gives me y cubed, and now I can start multiplying my like bases. So x squared times x to the 6th gives me x to the 8th. Y times y cubed gives me y to the 4th. So there's my final answer. 5 times 4 to the 0 is the same thing as 5 times 1, which is just 5. A squared times A gives me a to the cube, or a to the 3rd. And b times b to the 5th gives me b to the 6th. And just to make it interesting, we can have fractional exponents. So what we'd see is we'd end up with x to the 2/3 times y to the 1/3 times z to the 4/3. And then over here, we'd get x to the 2/6 times y to the 1/6 times z to the 4/6. And now I can start to add my exponents that have the same base. So x to the 2/3 times x to the 2/6 is the same thing as x to the 1st, because 2/3 and plus 2/6 is just 1. And 1/3 plus 1/6 is half, so I get y to the half. And z to the 4/3 times z to the 4/6 gives me 2, so I get z squared. All right, and with that, I would say it's a great time to try applying some of those rules on our assignment here, 6.1.1, and we'll see you in the next video.